So after finishing our component list, you will find out that it has been removed from the required information, and we are left here with the fluid package. We are asked about the property package or the fluid package. They are the same, fluid package and the property package. The difference might be one of them include the component list. So here the property package and the component list together form a fluid package, but it doesn't matter, they are almost the same. Okay, so here we need to go to the fluid package over here. It's in red, we need to turn it in blue like the component list of the natural gas over here. So I'm going to click the fluid package, and the fluid package is the equation or the model or the thermodynamics that is governing how the components will be acting together and what is the physical properties of each component. Okay, so most of the time, if you are dealing with hydrocarbons, it's recommended to use a fluid package called Peng-Robinson. Okay, but to make sure that you are choosing the right fluid package, here you have a method assistant. So if you are choosing fluid package and go to the home, you will have at the beginning the component list, and second thing, here you have a fluid package. If you click the fluid package here, it will show you the same page right over here. But if you need an assistant to tell you which fluid package that you are using, here you can find it here. So here you have a method assistant. If we click over here, you will find this page open. Okay, what is in this page? Here, the Aspen HYSYS property package selection assistant. It will ask you if you are dealing with oil and gas processing, if it's a refinery, a chemical industry, electrolyte, environmental, and so on. So in this case, I am creating a simulation for natural gas. Natural gas is oil and gas. Okay, so I am going to choose oil and gas because I am working with my feed stream to be natural gas. So it's an oil and gas processing. So in general, we recommend the use of cubic equation of a state-based property package such as Peng-Robinson, CBE, SRK, and so on. So the first one that is recommended if you are going to use the oil and gas processing is Peng-Robinson. That's why in my case I am going to use the Peng-Robinson. Okay, if you want to know more about Peng-Robinson, just in case it wasn't covered in your undergraduate studies and so on, so you can click here in the Peng-Robinson and you will find all the information that you need about the same using Peng-Robinson as a model or fluid package. Okay, so here you will have the general information like the range of pressure and temperature. For the Peng-Robinson equation, this is available, this data is available online. You can search for Peng and Robinson. These two have used a complicated model. They use a complicated feed, and from the natural gas complicated feed that they used to have, they have created a cubic equation. This equation, instead of doing the test at different temperatures, they have done the experiment for a specific data, and from the equations that they have created, you can find the physical properties of different at different temperature and pressure. So here I find out that you can see also the Peng-Robinson calculation method. Okay, so these are the equation. So instead of doing the search online, it's already available inside here. We reach this one by clicking the method assistant. Okay, for the Peng-Robinson cubic equation, it's we know about the general gas law. This is PV equal nRT. Here, this is a more advanced equation for the real gas. Instead of having PV equal nRT, here we don't have the compressibility factor into consideration, which is important. So it will take a lot of real properties into consideration. Like we have a compressibility for the gas. When we increase the pressure, the gas become more compressible. When we lower the temperature, the volume of the gas also shrinks. So if you are interested to learn more about the Peng-Robinson calculation method or the cubic equation, you can find it inside. So now I am trusting the fluid package assistant, and I know that I can choose Peng-Robinson. So in this case, I'm going to press add. When I press add, you will have the basis one. This is the name of the fluid package. I'm going to rename it. This is clicking rename, and instead of basis one, I am calling it NG, which is abbreviation for natural gas. Okay, so now this is NG for natural gas. So okay, and I am going to scroll down over here and look for Peng-Robinson. So this is Peng-Robinson. When you choose the Peng-Robinson, the property package PKG is for package. Status will be okay. Okay, so now after choosing this one, we have our component list defined, my fluid package defined, and here we don't have any message appearing, which means we can now enter the simulation environment. So now we were at the properties. Now we can enter our simulation environment because we don't have any more information that we need to add. Okay, when we enter, you will have this one, which is the model palette. Okay, I'm going to maximize the model palette here. The model palette here is like a shopping cart. You have all the utilities or the unit operations that you need to add during the simulation. So you can have all of them presented, or you can view them one by one. Like the first one is for the dynamic and control. This is a little bit advanced. Now we are dealing with a steady state simulation. This one will be added when we are transferring our steady state to a dynamic state by adding a BID controller and so on. Here you can add some external models. Here this one is related for the heat transfer, like if you have a cooler, a heater, a heat exchanger, a fan heater, and so on. The manipulator here is like unit operation, is like a unit operation that doesn't exist and you can't see it in the plant. They are added because they are simulating a function. Like if we have a recycling, we are taking part of the produced outlet and recycling a section of it. This is like a pipeline inside the plant, but we can't present it here, so we use something like the recycling. We will be covering all of this manipulator moving forward. This is for the pipeline and the hydraulics, the pipelines and how to add the pipe segments, the mixer, the T, and so on. Here the pressure it changes. We use a pump and a compressor, the pump for liquid. Here you have a compressor for gas. This is an expander. The expander does the opposite of the compressor. Here we have two types of sub-valves. This one is a control valve and this one is a relief valve. For the reactor here, this is more inside this one, we are having a reaction, which means we are dealing with a complicated or a more complicated than the separation. It's a chemical reaction. And this one, this is the simplest. We have a separation. It can be 2-phase, 3-phase, or you can use a distillation. Also, there is a cyclones over here. So this is the model palette. You can add what you want. So if we are simulating a distillation, you can write here, or simple 2-phase separator. So you can write here separator, and this one, this is a 2-phase separator, and this is a 3-phase separator. Okay, so this is the first thing. If you don't know about what is the mixer or what is the T, instead of viewing this one, the views here, this one shows them like an image. If we click this one, they will be showing, or the unit operations that you have, it will be showing as a list. It will show you the image, this one, which will be appearing in the HYSYS. This is the name. It's a mixer, a T, a heater, a cooler. What is the description like? What is the mixer? The mixer combine multi inlet feeds. So I have different feeds and I want to mix them together to have at the end one exit. Okay, so if I want to know what is the compressor, you can write the compressor over here and it will show you how the compressor will be shown inside your simulation. This is the name. It's a compressor. and the description or the function. The compressor could be centrifugal, reciprocating, or screw compressor, and it increases the pressure of the inlet gas. Okay, so and they also calculate the stream condition or efficiency. So if we can increase this one for the description to calculate the stream condition or efficiency. Okay, if you want to know about the recycle, the one that I've talked before, this is how it will be presented in HYSYS. It's named recycle, and it will assist as a solver in conversion. So why it's a manipulator? Because it's helping our solver to converge. We want at the end of the day our steady state simulation to be converged by transferring stream condition to the next iteration. Okay, so this is the recycle. So again, I'm going to make it smaller, and instead of viewing them like a name with a description, like if here I go to the heat exchanger or heat transfer, you will find heater, cooler, heat exchanger, and each one with a specific description. I prefer viewing them like this, and I'm going to delete this one and as all, and I can search for each one. If you need to learn more, instead of having this simple description about each unit operation, it's recommended to take it and Google it. It will be way better to learn more about each component. Okay, so here they are just adding a simple definition. So this is for your model palette and the information that you have. Also inside the model palette, you will have, we have covered the view, we have streams. Here we have three types of streams. The first one is the material stream. The material stream is the stream with the material, as the name suggests. Or if we have a pipeline with water inside it, this will be the material stream of water. Okay. Secondly, we have an energy stream. This will be used for something like a reboiler or a condenser. This material uses an energy stream. The energy stream here will be presenting maybe a heat in for the reboiler or the heat out for the condenser. Also for the energy or the power stream, this is more for if we have a pump or a compressor, we need a power for them to change the energy over time. Okay. We have also two types of flow sheets. Here, this is the standard sub flow sheet, and also there is another one which is EO sub flow sheet. We will cover these two. Okay. So at the beginning, I have a material stream, or I want to represent my natural gas. Okay. So here you can add the material stream of natural gas.